nu, 3h nu. Okay, it never be as a fraction of quantum. It should be multiples of quantum. That is h nu, 2h nu, 3h nu, like that. So if there are now two energy states, okay, E1 is there and the E2. So in that, the transition when takes place between these energy states, when the appropriate energy is either absorbed or the emitted. Then according to the plan, this energy is also quantized. Means what? Even, okay. First, it is the energy state is E1, and then after absorbing energy, it is going to the E2 state. The difference between them, that is delta E, okay, which is equal to h nu. So this energy is also quantized. We will see the electromagnetic spectrum. So see, there are wavelength. So the wavelength is expressed in different units in different spectral regions. So normally the electromagnetic spectrum, it consists of see the various it consists of different energy regions. The various electromagnetic radiations arranged in the decreasing order of the frequency or increasing order of the wavelength in that electromagnetic spectrum. Normally, this electromagnetic spectrum, see the part uh, below that waves, okay? There is a gamma cosmic rays. Besides that, there is a X-ray. Then there is a ultraviolet, then visible, infrared, microwaves, radio frequency spectrum. Then there is a here geomagnetic and the sub-ELF sources. Basically, this electromagnetic spectrums, okay, is divided into different parts according to the energy region, spectral region. So, see, normally frequency and the wavelength, these are inversely proportional. Means nu is equal to C by lambda. The nu is equal to frequency is equal to C, that is the speed of light, divided by lambda. So, C by lambda. So, lambda it is the wavelength. So, in proportion to this means as the frequency decreases, wavelength increases. If there is a nu means what? We have seen here H is equal to E is equal to H nu. Okay. So E is directly proportional to nu. So that nu, it is the wave number. Nu, it is the wave number. It is defined as the number of waves per centimeter in vacuum, and it is reciprocal of the wavelength. So nu, we write it as a nu, and there is a horizontal line above it. Okay. So that is the nu wave number. That is the wave number. And when we write only nu, that is V. Okay. Only we write V, then it is a frequency. There is a difference between the wave number and the frequency. So frequency, it is the number of complete cycles per second, and this wave number we represented at nu like V, and there is a horizontal line above it. So this is the wave number, is the number of waves per centimeter in vacuum. So nu bar, okay, we call it as a nu bar. That is the wave number. So nu bar is equal to 1 by lambda. That nu, that is the wave number, is inversely proportional to the lambda. And nu is equal to C by lambda. So which is equal to C nu bar. It means the wave number, it is the reciprocal of wavelength. Nu V bar, okay, is equal to 1 by lambda. Wave number, it is the reciprocal of wavelength. Now see, in this electromagnetic spectrum, there are different regions, spectral regions are there. So there is a non-ionizing part is there and ionizing part is there. Okay. So as you go, see in the middle you see there is a visible region. So visible region, it comes from 200 to, see here written, it is around 400 to 800, we say. It is around 400 to 800 nanometer. Visible region, 400 to 800 nanometer. Now, see the above scale is there, but you will not understand this properly because it is given in the hertz. So, you see the middle part, okay, that is gamma, X-ray, ultraviolet, visible, infrared. So there are different spectral regions. The visible region. So visible region wavelength, its wavelength range is 400 nanometer to 800 nanometer. Means under that comes the sunlight. Visible region is 400 to 800 that we can see sunlight because we can see the things, okay, we can see the object. So 400 to 800 nanometer, in that comes the visible region. Then there is a ultraviolet region. See, ultraviolet region, it comes between 200 nanometer to 400 nanometer. UV rays, we call it as 200 to 400 nanometer. Then here, after that visible region, there is an infrared region. So in the infrared region, there are Basically near infrared region is also there and far infrared region is there. This IR region. So infrared region comes in the range that is the 15 micron to almost zero point 0.8 micron. Okay, micron means what? Nanometer. See what is meant by nanometer? Anyone can tell nanometer?
Yes, ma'am. It is 10 raised to the power minus 9 meters.
Yes, yes. And these micron mean 10 raised to minus 12, I think. Okay, it comes. So IR region, it's calculated in the micron, that is 15 micron to zero point 0.8 micron. So that is 10 raised to minus 12. So visible region is there. There is a IR region C and there is a UV region. And after that UV, there is a X-ray. So X-rays come in the region like 10 raised to minus 2 nanometer to 15 nanometer. X-ray region, its wavelength comes in the range 10 raised to minus 2 nanometer to 15 nanometer. And see, normally the X-rays, normally it is used for the medical X-rays. Okay, X-ray we go for the medical checkup. So in that X-ray, so in that we can see if we have some fracture or something we have to check it. Okay, so we go for the X-ray and we can see. So what we cannot see by our eyes. Okay, so X-ray it shows our that fracture, that is the bone structure. If it is a fracture is there, so we can use the X-ray for that. So that region, that energy is different. So X-ray used for the medical. There are different uses, but normally it is we go for the X-rays to see if there is any fracture or not. So that we cannot see by our eyes. So X-ray that comes between 10 raised to minus 2 nanometer to 15 nanometer. Then there are the gamma rays, which are the cosmic rays. So going from UV to gamma rays, okay. So there is a you can see increase in the energy. When you go from visible region to this cosmic, okay, cosmic gamma rays, cosmic. So in that visible, then after ultraviolet, X-ray, gamma, cosmic rays, so their energy goes on increasing. And see, after visible, there is a infrared. So now I think when you have to, there are IR spectrum also, okay? So in the IR spectrum, there is a NMR. If we have to see the, if I made some compound, okay, I have synthesized one compound and I have to see the functional groups in that compound. What functional groups present? So I do the IR for that compound. So in that, I can see there is a actually that part is different one. You will not understand now actually. So basically IR region, okay. So that is used for the I'm telling you for example, okay. I'm telling you as an example. If I synthesize one compound, so I have to know that what structure it is made up of, okay. So there are different spectroscopies are there, okay. So there is a IR spectroscopy, there is a NMR spectroscopy, then there is a UV visible spectroscopy. So they are of different energies. So in that I can see now NMR spectroscopy. So in that there is a C13 and the 1H NMR is there. So in that 1H NMR, I can see the protons, that is coupling and all, how many different types of protons are present. Then if I have to know about the functional groups in that compound, then I will go for the IR spectra. So in that, I will come to know that what different functional groups present in that. So basically IR region, okay, that is the infrared IR region. It comes between 15 micron to 2.5 micron. Then after infrared, there is a microwave region. So microwave region, it comes between 2 into 10 raised to minus 2 centimeter to 30 centimeter. So now microwave, see nowadays there is a green chemistry, there is a environment protection. So reactions are going green. Means like nowadays there are reactions can be made in the microwave. We can do the reactions in the microwave. So basically that particular region of energy. So in that, so in the microwaves, there are the reactions which we can carry out by using the microwave. Now there are microwaves means like what we are using for the cooking. Uh, that is the we can use it, but normally there is a modification in that, and there are particular microwaves are there that particularly made to carry out the chemical reactions. So nowadays that reactions like called it as a green reactions. So what happens normally when we do the reactions in the microwave? So there is a so whenever we heat, now we have to heat the see, there is a one pot I have taken and I have taken the water in that. So when we put that on gas, so first that pot will become hot and then that water will become hot. But in the microwave, that heating process is different one. When I put, when I heat that pot, okay, containing that water, and I keep it in microwave. So there the heating process starts from the center itself. So that's why what happens from the center, it will start, the heating starts from the center and then slowly that water will become hot. So microwave region, that is the different thing. And nowadays there are the reactions we can carry out in the microwave also. So microwaves are there and the satellite. that comes the satellite, okay, in that region. Then after the microwave, there is a radio frequency spectrum, radio waves. So in that region comes between 30 centimeter to uh, 2 into 10 raised to 5 centimeter. So see the radio frequency in that we can there is a cell phone that we use PCS. There are the examples for that. TV is there. Then mobiles and FMs. Okay, that region, frequency region, that is the radio frequency. We can hear that FM. So that is because of radio frequency. Then there is a very low frequency is there, okay, CRT monitors. Then extremely low frequency, AC power. And the other part that is actually not main part is what? That electromagnetic spectrum consists of different spectral regions depending on the energy, its wavelength. Okay, every this part is it is of different energy. Now basically visible region, so it comes between 400 to 800 nanometers. We can see the things, okay? We can see the things in that range, 400 to 800 nanometer, it is the visible region. So in that region, we can the things, we can see the object, we can see anything like, but UV region that comes between 200 to 400 nanometer. So UV region is there. Then there is the X-ray and there is the gamma rays. So there are different types of spectral regions.